So this talk is about how V14 is like blazingly fast without rewriting it in Rust. That's a Rust joke. Like there is trend going on of rewriting everything in Rust to make it fast. But what we have observed is something else. And I'll just walk you through how we have made the performance improvements in V14. And basically, you can apply the same principles. And if you have similar problems on your performance problems, and you can learn something out of it maybe. So just broadly, the improvements that we have done is our response times are lower, we use lower memory, we have lower bundle sizes, we use less disk, and it feels faster. So everything is sort of better in all sort of performance metrics that matter. And that's why we suggest everyone to first upgrade to V14 if you are facing any performance problem. Then we will discuss if the problem is still there. So again, like just to reiterate, like everything is faster in V14, upgrade to V14. So because all of these things that you saw, these were reported by someone, like someone had problem with these things, and that's why we worked on them. And so what are our sources? Like how do we identify what is slow and we need to focus on improving it? So one of our first sources, like we have a huge paying customer base, and when they feel something is slow, they report it to us. They are like, desk is loading slowly, submission of invoice is slow. So this is our main source of, and that we need to work on. And we also provide plans for like very large database, like if you have scaling problems with thousands of invoices, etc. So this is our primary source of getting information about performance issues. The second is Frappe Monitor. So if you don't know what Monitor is, I'll briefly touch upon it later, but it's basically our inbuilt monitor of how any site is performing. So we monitor how a request works, or like how much time a request is taking and how much time some background jobs are taking, etc., etc. And we have a Elasticsearch to like ingest all this, thanks to Aditya. We use Sentry internally. We don't have it in core because open source data collection, etc. But on our own sites, we use Sentry to monitor errors and performance things. And lastly, like all these other things don't matter much because it's just developers scratching their own itch. Like why is this so slow? Why is this not fast enough? And that's the primary reason why we figure out most of the performance issues. And Sagar is laughing right now because he has scratches in itch on so many places, and we'll see it later. So I've tried to theorize all this a bit. This might feel like a college lecture, but it's not. Wait. So we have, I have broadly categorized the performance things, performance fixes that we do in 3 things, which is like known unknown metric that you have probably heard of. So there are known problems, there are known unknown problems, and there are unknown known problems. There are unknown unknowns that we just forget about. So let's start with like very specific known problems in performance. What are those? So the most common is a document and it is taking some time to submit. This was a real problem a year ago where stock entry was taking some time for if you have 100 items, it's taking too much time. So what we usually do is you just profile it with inbuilt profiler. Python has great profiler inbuilt. You just add prun, which means profile and run this command. So first you need to figure out what is the entry point for whatever you're looking for. So here you need to have some baseline understanding of framework, like when something happens on front end, what happens on back end. If you can figure that out, then you can just profile it and just fix whatever is slowing you down, and then there is profit. It's not that simple, the dot part, I will come to that. So the dot part is this. You get this giant thing, and I am sorry if the font size is not good enough, but it's not, you don't need to focus on this too much. Basically, when you do prun, you will get what is taking what amount of time. So by function, like submit took 18 seconds, and out of all this, 1.7 seconds was taken by some function, which we don't believe should take this much time. So there is one function called getInvalidLink, which is taking 1.7 seconds. It's like 10% of this. Why is that taking that much time? And for those who don't know, invalid links is like our own foreign key implementation. And I know for sure someone will talk about why you don't have foreign keys, but let's not get into it now. So basically what we found out is someone wrote this code where they were removing the entire cache for the foreign key validation. And because that cache wasn't there, every time we were hitting the DB and it was slow. So the dot part is usually just reading the code. There is no escaping that. Like once you figure out what part is slow, you just need to read the code and figure out like someone somewhere messed up, and that's why it is slow. And now another tool that we used for the same problem was Recorder. So Frappe Recorder is this inbuilt profiler of SQL, all the SQL queries that happen. And I can maybe show you a live demo of what this does. So for example, yeah, it's still working. So let's take the similar example. I have one stock entry here, which is in draft mode. I want to see what happens when I submit this. So what you can do is you just go to Recorder and just enable it. So this will start recording everything that is happening. This will make your site instantly slow, so don't like enable it all the time. But when you are trying to optimize something, you can enable it and see what is happening. So you saw something happen that was in other tab, like just something happening in background. But let's say what happens when I submit this. So that went through, and now you see the request. And the first one is what we care about is like what happened when I saved the document or submitted the document. There's too much info here, but usually what you care about is like what queries were fired, how much time it took, and this is sorted by default, like what took the most time. You can see the query, you can see the duration, and if you know if you can pass the explain output, you can see it here. Like everything is automated about like SQL optimization if you use Recorder. You just need to read this and you'll get much clearer idea of what is going on. So coming back to the presentation, so we ran Recorder on that, and we found out that there were duplicate queries. So if you see 300 queries, 299 queries, which were literally exact copies because our foreign key validation code was not using cache. And this is how you figure it out, and then you just root cause it till you fix the problem. So that was about generic very targeted performance problem where you know where the bottleneck lies. This is another example that was about CPU. This is about memory usage. So this is a real problem. This was back when I was in ERPNext team in stock. And the reposting, the infamous reposting, used to crash on very large jobs with, like it used to reach gigabyte of memory, and then Frappe Cloud is like, itna sara, you can't use this much memory, and we'll just kill you. So background jobs would just get killed out of nowhere, and you will find it in OOM logs that this was killed because it was taking too much time. It was taking too much memory. So now here the problem is very different from CPU. So you need to use different tools for that. So Python doesn't have any inbuilt memory profiler as far as I know, but the most popular one is memory profiler. And what you do is you figure out which job is or which task is taking too much memory, and you add this on top of it and you run it again. And what happens next is you get a similar output, but here you see like in that, this is roughly what reposting does. I can't show you the actual code, it's quite large, but it's basically looping over like multiple documents and trying to process each one of them sequentially. So what was happening is when that get doc happens, like you get a new doc, we were continuously increasing the memory. And this feels wrong if you know Python. It has an inbuilt garbage collector. So if something is not used after for loop, Python can actually kick it out, and that shouldn't increase memory. Like your memory size should be roughly what one document is, not what 100 documents are. So this was the problem we observed, and the root cause for this was quite weird. Like you'll just have to narrow it down, keep narrowing it down. Like getDoc was a problem here. So we saw why getDoc is increasing the memory, and root cause of this was quite weird. I can show you live. So let me see if I can get this frappe.get cache doc. Yeah, let me just do any cache doc. So I just fetched cache doc. So what happened here is I have not assigned it anywhere. So like ideally, if I press enter one more time, or I say I do anything else, that should go out of memory. But it doesn't, because like internally we also cache it in local. So it is frappe local document cache. And it is there, just sitting there. So when you do 1,000 get cache doc, thousands of them are sitting right there and just increasing the memory usage. So we realized that we were doing over caching where caching wasn't required. So our Redis memory usage was up, and it was killing it was getting killed. And once we found that out, we fixed that issue of the incorrect cache implementation, and now the memory usage is like nearly linear, like no matter how many documents you process. So this is there's like infinite percent improvement because from linear growth to constant growth. So that was another specific example where you need to profile memory. Now the another pattern is you don't know which overheads you have. Like you understand the system, but you don't know these things exist, like these problems exist somewhere. But so how do you figure out where these problems are? And the most common is like our response times are slow, means the desk is taking too much time to load, or I'm getting response somewhat slower. So there is no entry point. Like the desk is one large WSGI app. You can't just say cProfile this or run it in console. It's a continuously running process. So you can't use something like that. So here again, you need to pick the right tool, and there are many sampling profiler. So sampling profilers are something that attach on a process. Like if your web server is running, they will attach to that process and just continuously monitor like what is going on and where you are spending the time. So we use a tool called PySpy. There are 3, 4 many. If you want to discuss, we can discuss later. But we used it. We found some overheads, and we reduced that overheads, and now like suddenly most of our typical requests have like 50% lower response time. And it's hilarious. I won't get into too much detail here, but what you see in the blue box is all useless overhead. And this, if you are doing a get list, the other half is the actual code, and this half is the boilerplate code. And what was happening is someone did get doc instead of get value, and that fetched entire doc, entire meta. So if you understand, like it fetched way too many things which it didn't need to, and that was the root cause of this. So it's not like very technical problem. It's just someone didn't give enough attention where this code is going to get used, and that's why everything became slow. As you can see, like when I said we monitor every site's request log, so we monitor roughly how much time a request takes. So this is our own site, and we were checking like how much time a notification like when you fetch notification, how much time it takes. So it was taking around 300 milliseconds. We fixed it, and that dropped down straight to like 20 milliseconds. It's just this was again like very basic. Like we weren't using the index, we ourselves added, and we fixed that, and you just like suddenly see the drop. So here is where our the whole FC monitoring, the infrastructure part comes in. Like as a framework developer, I don't usually have access to too much data, but now that we have proper performance data, we can actually focus on the important things and see that that actually made some impact when we fixed it. So this was one of those. Another overhead we typically heard is like you have like 5 megabytes of JavaScript asset, and we'll hear about JavaScript a bit more, but it's here to stay, and we need to fix it. Like we can't have 5 megabytes asset sizes. We need to reduce it because load time directly depends on it. So what we did was like we again tried to find a tool which lets us visualize like what is in our bundle, and there is a lot of crap obviously. And what we found, like surprisingly, one of the major finding was we were duplicating an entire bundle in 2 different bundles. And once we removed that, like it went from 5 to 4 MB, and then we removed a little bit more, which we can load asynchronously. So bundle size should, like we hope this reaches like somewhere around 2 to 3 MB, but right now is somewhat better than what we had before. And this is how you figure out when your like asset size are growing quite large. So you need to use some tools that can let you visualize it. Because otherwise, like, what are you going to do? Like, read every JavaScript file? That's not going to happen. And surprisingly, like, the root cause of this was just one line import somewhere that increased the size by 1 MB. So it's very difficult if you don't use the right tool to figure out like where that problem is coming from. Again, this is too much disk usage. So people who use the $10 sites or $20 sites, they usually complain, why is my site taking so much space? I don't even do this much work. And the first obvious step is you just see like which table is taking too much space. Like just start with the obvious thing. And we found out which tables they were. They were mostly logging tables, sometimes version tables, and email queue, the infamous email queue. Some of them, they were taking the most space. So again, there is ... part where you figure out how you can reduce the space that is using, and we achieved like somewhere from 10 to 50% drop in database usage. So our own internal site is now more than 50% consuming more than like 50% of the database size is gone. So we went from like somewhere from 5 GB to like 2.4 GB. And if you upgrade, you will get this for free because another improvement that I'll explain later. So what was happening here was, this is one example of version doc where we try to optimize the space. And what you can see here is there are multiple things wrong with this. The first is this is a version lock for a log, which makes no sense. Why do you create version for logs? Logs are just static logs. There is no need to do this. So first of all, this whole thing wasn't required. Second is minor thing. You see the /n. This is indented, so someone can read it properly. JSON, the JSON file, someone can read it if they are looking at it directly. But no one reads this directly anyway. So we don't need the indentation. And like you won't believe, but the indentation alone is like 22% reduction in the version table. Just white space. And lastly, if you look at the actual data, like if you understand what version diffs are basically when you say you have a document and you modified something, we keep a track of what you have modified. If you see this, there is nothing logged here that is not already available in the document, like who created this and when they created, which is already there. Like there is no need to create this. So we removed like these 3-4 problems, and this alone was a huge contributor to reducing the disk space. So coming to the next pattern where you know these things exist, but you don't know how they are causing or how or where they will cause the performance problems. So here, the best example I could find was our client library. We use PyMySQL, which is written in pure Python. We used to use MySQL DB. Then we thought it crashes too much, so we went to this. So it is slower. It is quite slower. Like if you look at, like just by swapping this library, you can get 2.5 times the performance improvement. It also crashes 2.5 times more. So far we are not using it yet, but this will land in stable branch someday soon. Like I'm guessing like maybe 2 to 3 months. But when this happens, your queries are automatically 2.5 times faster. Without doing anything, like we are just swapping the library. We do a little bit of work to make the library work with everyone's code, and then everyone gets a benefit. This is another weird thing. I'm sorry if you get triggered by Orange Man, but so when you heard about the logs thing, where we were logging unnecessarily, and we need to now get rid of those logs. So I naively wrote a query, delete from this where modified is less than something, and that was supposed to delete like gigabytes of data from database, which ran for 20 to 30 minutes, and then it crashed. Because we have this abstraction, we believe that delete is so simple, but it isn't. Delete has to evaluate the condition on rows, and then it has to filter out, and it also has to do it in transactions. So there is so many things going on, and if you are trying to delete like large amount of data, it just won't happen. So this is where you have hit the abstraction boundary of SQL, where you believe something to work the way it works, but it just doesn't. So, and this is there in the docs, like how do you handle, so there are many ways to handle it. You can partition tables, you can write SQL script to do it, but whatever you do, you can't optimize that query anymore, because that's just how SQL works. And what we ended up doing is like, what if we just take the remaining 5% of data, move it to a separate table, and swap the tables? So it was a much simpler solution than what we had before. So there is a patch that does this, which just copies the remaining data that is meaningful, the recent data, and just swaps the table. And it took seconds instead of minutes, and it actually works. So this was all about numbers. What about like feeling like, because ultimately what user feels matters the most. And here, I don't do much, but our client-side developers or those who work on front-end work a lot here. And what you might have seen is over time, we have added a lot of skeleton loaders. Like if the site is taking too much time, you see some kind of skeleton loader. So user is not like totally baffled if the site is even going to load or not. So numbers basically never translate one-to-one with what you are feeling. For that, you need to have decent UX on client side also. So this is one example. The skeleton loaders are one example. Another is this. So if you press this, like if you go to login page and type username, password, and press enter, it will, on first login, since it needs to generate a lot of data for you, it will just get stuck here for 2 seconds. And then it will show you a splash screen for a split second, and then it will load the entire thing. So ideally, splash screens are supposed to be loaded immediately. So, and this was bugging Suraj a lot, like, why is it that stuck there? So he was scratching his itch and he fixed this. And like now you go and press login, it will immediately show you the skeleton loading screen, and then it will jump to the desk. So these sort of things, they don't seem like much, but there are a lot of these things which I can't go into all of them, and you maybe learn a lot about them if you just go to GitHub and see like search by like if you filter by performance PRs. So I'll just broadly revisit what kind of tools we use and what you can use. So cProfile is an inbuilt profiler, which you can use when you have clear idea of what you need to fix. Then there is PySpy, where you don't have clear idea of what you need to do, but like everything feels slow, so you use that. For client side, you don't need to reach for anything special, like browsers have amazing dev tools. Memory profiler for memory, and we have our own tools because we know these problems are not just simple, that simple. So Frappe Monitor and Frappe Recorder for monitoring production and recorder occasionally when you are analyzing something. And ultimately, like when all of this fails, you need to write custom scripts to benchmark things. And we do write a lot of bash curl scripts to just figure out like how to replicate particular workloads, sort of. So like I said, I don't have time to go into all of them. Like there are way too many. But if you just look at all this, there are there are just way too many. So you'll have to go to GitHub and see like what are the improvements that we have done. But broadly, like wherever we felt this was the critical path thing and it is slow, we try to optimize it. And you will see a lot of, I forgot this slide, but you will see a lot of small improvements here also. The small in the sense that there are like microseconds of improvements. Like translation function is now 6 microseconds faster. That makes no difference to you, but when you see how many times it is called throughout a particular cycle, it adds up to a few milliseconds because it is called so many times. And Sagar here is nodding. He has done so many micro optimizations, and every time I cringe a little, like why first? And then I realize like, okay, this is called way too many times. So this is not micro optimization or premature optimization. It actually matters. So key takeaways are like, we are like apes. So don't trust anything. The code base is just way too large for anyone to have like clear idea of how performance of any particular system works. Our code base is large. Our dependencies are large. You also depend on us, so you have pretty much the same thing. So you can't trust anything. Like wherever you have a problem, you have to profile it first, and then only you jump to anything. Second is you have to know the abstractions you are working with. That is like you are using SQL, you are using Linux, etc., etc. If you understand them well, then you will realize where the problem is. Lastly, like learn some tools and write some tools. So performance is just way too big of a problem to tackle without any proper tools, and so that's why at least I focus too much on tools. And this is the key takeaway, that most performance issues, like all of the ones that I discussed, they are not deeply technical. They are, so there might be performance issues where, like at Netflix, where they need to profile garbage collector and disable garbage collector. We are not there yet. Like most of our problems are someone forgot to care about that this is going to be a critical path thing. So we are not there yet. So they are not technical. They just need a little bit of investigation to solve it. So what is the road ahead for us? So performance regression test, hilarious thing. The response time thing you saw, where we reduced by 50%. Then Gavin broke it. It went back. I fixed it. Then I broke it, and it went back. So whoever works on this, it's very difficult to keep track of that. These things don't come back somehow because, again, large system. So we started writing tests to make sure that this is not regressing back. Some few more things which are in plan. The persistent connection, we have heard this so many times, like do connection pooling. We'll do something alternate, faster desk routing, better client-side caching. You will hear about this in Faris's talk. And usually just more scratching the itch, because that's how we have done the most performance-related things. Just star and watch the Frappe repository if you want to find out more about this. That's it. I have added this slide, but I don't have much time right now. If you have questions, you can reach out to me anytime. And if it is very specific, I might not be able to answer, but I can maybe give some pointers. But if you have some generic questions, then maybe right now.